we started looking at type 1 PRMT inhibitors while I was studying C9orf72 mediated models of ALS. And when we talk about ALS disease mechanisms, we can think of two sort of main categories, I guess, of pathology that can go on in a cell. For example, one mechanism is called loss of function, where you might end up with toxicity resulting from an ALS gene mutation, for example, causing a normal protein to either stop being produced, so it loses its function by not being there at all, or altered in a way that stops it from performing its usual role. And the other sort of category is called gain of function, where you might have a mutated or an altered protein in the cell that gains a new role that is not good for the cell, or interferes with other cellular processes, causing toxicity. And I studied a lot of that second category, that gain of function toxicity, as it related to C9orf72 ALS. And over the course of that process, we got the idea that maybe we could exploit the existing machinery in the cell to modify these mutant proteins and see if that modification would change their behavior in a way that was positive and had good outcomes in cell-based models of ALS. And interestingly, in that process, we found that inhibiting the ability of the cell to change those ALS mutant proteins in a certain way rescued the toxicity that we had in that ALS cell model. And the drugs that did that were those type 1 PRMT inhibitor drugs. And that's kind of what took us from just studying C9orf72 ALS cell biology to using small molecules to modify C9 gain of function phenotypes in a way that rescues cells.